Hey everyone. So today we're going to go over what is an electric field. Now, if you can remember, in our previous videos we talked about like the force that's felt between two charges. So let's assume that we have a pretty big object that has a lot of charge. Well, the object doesn't have to be big, but has to have like a high positive charge associated with it. Like it's a big positive charge. And let's say we have like another object that has a small positive charge, and we're going to denote that by little q. So we know that this little q is going to feel a force due to the presence of big Q. And we know since they're both positive, the force is going to be pointed away. And let's just call it the force Fe. And we know it's a vector. It's important. And so, what is the electric field? So, the electric field vector, or the electric field, is defined as a vector E, and is defined, so this is different from equal. This means defined, not equals. So E, we're gonna say we're gonna make, when you say defined versus equal, when you say defined, E is defined, it's saying that it is this. It doesn't equal this, it is this kind of thing. I mean, that's kind of similar to equal, but it's kind of like you can define, there's a difference between define and equal. So you're saying that E, it is this. It is equal to this. You're not solving it and you're finding what E is. You're just saying E is equal to this. So E is equal to the force vector E that's felt by an electric charge due to the presence of another electric charge divided by that charge's charge value. So in this particular case, it's going to be Fe here divided by Q, which is here. So if we look at Coulomb's law like we did in the previous videos, we know that Fe is going to be equal to Ke big Q times little q divided by r squared. And so that's what Fe equals. And we had divided by Q over here. So we see that the Q's cancel out. And when we're left with E, I'm going to put the unit vector R1 to 2, 1 being big Q, 2 being little q. Q r squared 1 2. So we can see that the electric field is equal to this value here. So one thing to note, so that's basically saying that the electric field is independent of whatever charges are around this big Q charge, right? So this is basically, if you kind of think about it, it's like in this particular case, Ke and Q are constant, R squared varies. So if you look at this Q again, we'll just look at this because I think this would be helpful to look at. This big Q, you can see that the you can see that the magnitude of the electric field, because we know that since r squared, we know that there's a distance r, there's going to be one magnitude of the electric field. And if we go like further out to another distance r, r2, we know that's going to have a different magnitude for the electric field. And we know that this circle is going to be equal to the magnitude of electric field on the circle line is going to be equal to E2. We know the magnitude of the electric field in this smaller circle is going to be equal to E1 for this radius R1. So we know that R1 is less than R2, and based on this equation here, we know that that means that E2 is less than E1, because R is getting bigger, so that means E is getting smaller. Okay, so that's one way to kind of think about this electric field. So all it's saying is that whenever there's a charge, the charge itself sets up an electric field around it. And so that's all it is. So there's, and if it's like a spherical, if it's like a point charge, it's going to have this like spherical, the spherical kind of behavior, spherical, where the electric field will decrease with r squared as you go away from the point charge, and you can see that there's going to be like the same magnitude of the electric field around each concentric circle for a point charge. So that is what electric field is. One note I want to kind of mention is that if you have like a point charge and a charge Q, if these were like if we're assuming here that big Q is a lot greater than little q in terms of its charge, right? So big Q is a lot greater than little q. If little q was maybe like proportional to big Q, you might have these charges on this point charge here move around and become, have a different distribution, and that can actually affect the electric field that's generated here. But assuming that little q is a lot smaller than big Q, you have this like concentric circles electric field that is displayed here. Because you can use the electric field to calculate the force that is applied on a test charge that is like brought within the vicinity of the electric field and the main charge that's going to be that's going to generate the electric field. So yeah, guys, so that's how the electric field is and how it's defined and some ideas about it. If you guys like this video, subscribe to this channel and give a like to this video. And if you guys have any questions, leave them in the comments below. If there's something specific you guys want me to look at, leave them in the comments below. And this is all, guys. So have a good day, and have a good day and enjoy your day.